All right, part C and hopefully part D of this problem. So it says determine the terminal speed of the ball as it moves downwards. So let's go ahead and do that. And I'm going to put some more notes here. We'll call this solution notes continued. And the way this is going to work is that we want to get the terminal speed as it's moving downwards. As it's moving downwards, it's going to have mg going down, and it's going to have this force kv going up. And the differential equation that describes it is mg minus kv equals ma. A could be dv dt, but we're not going to do that right now because what we want to find is the terminal speed. So at the terminal speed, a is 0. What happens is that the speed gets faster and faster until it bounces the weight, and then the net force on the ball is 0 and it coasts at constant speed. So mg minus kv terminal equals m times 0, and so we're going to get that vt equals mg over k. That's the answer to part C. Now let's talk about, does the ball, for part D, does it take longer for the ball to rise or fall from its maximum height back to the height from which it was thrown? So this is actually a little bit of a trickier question, but we can actually figure it out. So let's think about this. I start off at a really fast speed, and then I slow down and I reach my max height. So let's think about this. I have v fast to v equals 0. And of course, gravity and air slow me down. But now when I fall from my max height back to the ground. And what's going to happen is gravity speeds me up, and air still tries to slow me, or tries to slow the ball. Thus, what that means is that my v final here is not equal to my fast speed that I threw at. There's some dissipated energy, and so what that means is the time up is less than the time to fall. That's the answer to part D. We'll finish the graph in our next little set.